day learners, welcome again to another class, and I remain my humble self, Kamaldeen Abiona, and today I will be taking you on the laws of probability. The last time we looked at probability, and today we want to look at laws of probability. We want to go a bit further.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
We have defined before that probability is a branch of mathematics that deals with occurrence of random events. So today we want to see how we can use the laws of probability, the addition law and the multiplication law. So that is our objective for today. We want to see how we can employ or use the laws of probability to solve problems on probability. All right, so let's go. Yes, there are some important concepts that we need to define in probability. What are those concepts? Number one is mutually exclusive event. Event. You remember event at the last time, which means favorable outcome of an experiment. But today we are looking at mutually exclusive events. Now, what happened here is that we want to bring two events together. And that is what we want to do. We want to bring two events together, and that is what necessitates the laws of probability. All right, so two events are mutually exclusive if they cannot occur at the same time. For example, a coin flip can't result in both head and tail. You know, when you flip a coin, so it's either we have just a head or a tail. Also, another example of this mutually exclusive event is your being in school or at home at a particular time, at the same time. No, it's not possible. You know that. It's either you are at home or you are in school. So you can't be at the two places together. So that is an example of mutually exclusive event. So in that case, there is no overlap. Mutually exclusive have no common outcomes. That is, from the knowledge of set. Do you remember? Meaning that probability of, so meaning that in this case, A and B, A intersection B is not possible. It's not possible here. It is empty. It is empty. So as a result, the probability true does not exist. Or we say probability is zero. Probability of such, probability of A intersection B is zero. It exists, but it's zero. Yes, the second, another one, rolling a 6 and a 2 on a single die. You know, the two cannot occur together at the same time. It's only one of the two that you can see. So in that case, that is an example in just a single row. In just a single row. So the next one, probability, yes. When you are now calculating the probability of such event, the probability of either event happening is the sum of their individual probability. Yes. In this case, we want to look at probability that the two occur. So probability of A or B. It means it's the sum of their individual probability. So that is what they are trying to look at in that case. probability of A plus probability of B. In the case of mutually exclusive events. Why? Because we have mentioned that the two of them cannot occur together. So that is when we have such a result. All right. So independent event. Independent event. So events are independent if the occurrence of one event does not affect the occurrence of the other. The occurrence of one does not in any way affect the occurrence of the other. For instance, flipping a coin twice. When I have two dice, in a game of Ludo, for example, when we have two dice, if two occur on one die, doesn't mean two must occur on the other one. So they are independent. The two results are independent. So that is an example. So it means independent events, no influence, don't affect each other. Then the second one, drawing a card from a deck. You can draw anyone. If you are picking two times, it can be of anyone. So, and then drawing another card. So you can have different results. You can also have the same result. They are independent. Probability calculation. So how do you calculate the probability in such a case? So the probability of both events happening is the product of their individual probabilities. The product of their individual probability. Probability of the two of them occurring, P of A intersection B, will be equals to P of what? A multiplied by probability of B. All right, so that is, but we also need to talk about addition here too. Probability that either of the two occur, which we have done in the other one, in the mutually exclusive event. We talked about this in the mutually exclusive event. So in this case, how do we do this? Probability of A or B? Well, to do that, I will refer us back to our knowledge of sets. When you have two overlapping sets, how do we find the union? Because probability of A or B is also the same thing as probability of A union B. So in such a case, let me see if you have this. A, B. All right, you remember? So let's say this is X, the common one. Remember that this is A minus X, and this is B minus X. So in this case, probability of A union B here means you had the two, everything inside the circles together. So A union B here, or number of A union B will be equals to A minus X plus B minus X. Okay, so what would that be? This cancel this, and we have what? Number of A plus number of B minus the X, which is the intersection, which we can rewrite as number of A intersection B. Sorry, A intersection B. A intersection B. So in that case, borrowing from that, we can come to probability and say probability of A union B. Replace anywhere you see number, cardinality, with P, probability. Go to probability of A plus probability of B minus probability of A intersection B. All right. So that is, since A intersection B occur here, so it means probability of A or B, either of the two events occurring for independent events, will be probability of A plus probability of B minus probability of A and B. All right. So let's move on. All right. So have explained that addition law as a result of what we have explained in independent events and mutually exclusive events. So the addition law helps to calculate the probability of either of two events happening. It states that the probability of either event A or event B occurring is equal to the sum of their probability minus probability of both events, which have taken us back to the knowledge of sets to do that. So that is what we can have here. Probability of A is probability of A or B. A or B is probability of A plus probability of B minus probability of A and B. Okay, so let's move on. Multiplication law of probability, which I've also explained based on independent events. So multiplication law, in that case, we have independent event, probability of A and B is probability of A times probability of B. But if you have events that are dependent, an example of dependent event, an example of dependent events in case of mutually exclusive. So we also have cases, other cases of dependent events. So if you have dependent event, probability of A and B is probability of A multiplied by probability of B, given that A has occurred. You can see that. You can see that. It's not a mistake. It is probability of A and B equals probability of A multiplied by probability of B, given that A has occurred. So that is that. So let's move. We have been able to look at addition law. We have been able to look at multiplication law. So let's take some examples to illustrate that. Okay, a bag contains 5 red balls, 3 blue balls. What is the probability of drawing a red ball or a blue ball? Now, another important thing is that when we use the word or, the conjunction or there, you know, it's like operation. The operation, the or here in set or probability. The operation that will be used is union. Okay? And anytime you see and between two events, one event and another event, then the operation we'll be making use of is intersection. So here we have been asked to find probability of finding a red or a blue ball. Probability of red or blue. Probability of red or blue. Now what you have to ask yourself is that in this case, are the events mutually exclusive or they are independent? Yes, in this case, a bag contains, so what is the probability of drawing a red ball or a blue ball? If you draw a red ball, will that prevent you from drawing a blue ball? That is just what they are. Is it possible that at a goal, when you want to pick a ball, you realize that the ball is red and at the same time blue? It's not possible. So it means the two events cannot occur together, and as a result, we can conclude that they are mutually exclusive events. And when they are mutually exclusive events, what is their probability? What's the probability that the two of them occur? Either of the two of them occur. So probability of A or B or union is the same thing as probability of A plus probability of B, because the two of them cannot occur together. Yes, at a time you can't see a red ball and at the same time a blue ball. So here, what do we do? So that will be probability of red or blue equals number of red. From this, we have the total to be 5 plus 3. That's 8. Number of red, that is 5 over 8. Probability of blue, number of blue, that is 3 over 8. And all will give us 8 over 8, which is 1. So probability that either red or blue is 1. A coin is flipped twice. What's the probability of getting heads on both flips? What's the probability of getting head on both flips? In this case now, we have it has been flipped twice. So the results are what? They are independent. They are what? Independent. So what's the probability of having them together? So probability of what? Having head on both. Probability of head will be equals to what? Probability of head times probability of head. Yes. Heads on both. It means head on the first one and end head on the second one. So that is why we are using and multiplication. First one and the second one. So in that case, what's the probability of getting head on the first one? That is 1 over 2. Head on the second one, 1 over 2. And that is 1 over 4. All right. So we have been able to apply the laws of probability to solve this question. So let's look at other. So more questions. We have a die is rolled. What is probability of getting an even number or a number greater than 4? An even number or a number greater than 4. How do we do that? Even number. Even number, we have 2, we have 4, we have 6. Or a number greater than 4. A number greater than 4. You can use F for that. A number greater than 4. What are those numbers that are greater than 4? Yes. Good. Greater than 4, that is 5 and 6. All right. So what's the probability of having either of the two? Either even number or a number greater than 4. You have to be very careful here. Yes, that's good. Even number or a number greater than 4. Is it possible when you pick an even number? Is it possible that that same number will be greater than 4? Yes, it's possible. An example is what? 6. 6 is an even number, and 6 is also what? Is also greater than 4. So how do we do that? It means it will be probability of E. Probability of E or F will be equals to probability of E plus probability of F minus probability of what? Minus probability of E and F. Because in this case, it is not, they are not mutually exclusive, they are independent. And as a result, you have to use this formula. So how do we do that? E, that is 3 out of 6. F, that is 2 out of 6. E and F, combination of the two. That one that I'll call, that is both an even number and is also greater than 4. And that is just 6. So, which is 1 out of 6. So this is 5, this is 4 over 6, which is 2 over 3. All right, I hope you get that. So that is 2 over 3. 2 over 3 for that. So let's go to the last question here, which is a bag containing 4 red balls and 2 blue balls. 2 balls are drawn without replacement. What is the probability that both balls are red? How do we do this? Now, both balls, anytime they use both, from our knowledge of English language, so it means they are referring to hand. We are using the conjunction hand to represent that. So in this case, we are looking for probability that they are both red and red, and that is multiplication. But in this case, from dependent event that we have mentioned, these events are dependent because they said without replacement. You are picking without replacement. Initially, we have 4 red balls and 2 blue balls. So, and the total in that case is 6. So, probability of picking red first. So, our probability of red will be probability of red multiplied by probability of red, given that red has occurred first. At the first time red has occurred. That is, I told you, it's not a mistake. So, that is. Let's see how we can apply that. Okay. So probability of red at the first pick. How many red do we have? 4 out of 6. Multiply by. Now when you have picked red, it means when I go to the what? When I go to that particular bag, what will I find there? I'm going to find 3 more red and 2 more blues because I've removed 1 red without replacing it. So I have 3 more and 2 more. And the total I have is now what? 5. So what is the probability of picking red again? And that is 3 out of 5. 3 over 5. So this 3 here 1, 3 here 2, 2 here 1, and 2 here 2. Okay. So from that, what do I have? I have 2 over 10. So is it 2? No, sorry, 2 over 5. I have 2 over 5 as the answer for that. So thank you very much. I hope you have found it very interesting. You just need to study more to be able to see that. So we can apply probability in so many areas of life. In game of chance, we can apply that in medical research, different word scenario, and that is what you can see there. All right, so our conclusion, you have been able to learn mutually exclusive events. We have been able to learn addition law and multiplication law of probability, and at the same time, we have also looked at independent events and dependent events. So let's take time for the practice question. So I have a practice question here for you. 2 dice are rolled. What is the probability of getting a sum of 7 or a sum of 11? So you have just a minute to quickly look at that. Thank you. You are welcome back. I hope you got that. Yes, I remember we have done probability of getting a 7 before, and now a sum of 7. We are looking at combining them together. So how do you see that? Okay, so probability of 7. So it means we need to get our sum table. Yes, if you remember what we got the other time, let me quickly do that here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so this is 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. This is 4, 5, 6, 7, 8, 9. This is 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. This is 7, 8, 9, 10, 11, 12. So let's quickly do that. Probability of having a sum that is 7. Sum 7, 1, 2, 3, 4, 5, 6. So probability of having a sum 7 is 6 over 36. The total is 36. We have done that before. A sum of 11. 1, 2. That is 2 over 36. So can a sum be 7 and at the same time be 11? No, it's not possible. So it means they are mutually exclusive. So they are mutually exclusive, and when you are looking for probability of either of the two, we simply add, and that is 8 over 36. 4 here, 2. 4 here is 9, and the answer is 2 over 9. I hope you have enjoyed yourself in our journey through the study of probability. Yes, what you just need to do is practice more questions. If there is any question, comment, you can always make use of the link displayed on the screen. Thank you very much and have a wonderful time.